Right, grade 12, here we are again with the Eastern Cape September 2019, September exam rather. And for grade 12, it's a mock exam, and we're doing question 4, which is our momentum and impulse section question. Two ballet dancers, A of mass 52.5 kilograms, moving with a velocity of v meters per second in a straight line to the east, and B of mass 42 kilograms, moving with a velocity of 4 meters per second to the west in a straight line, approach each other as shown in figure 1. The two dancers grabbed each other and came to rest as shown in figure 2. Ignore the effects of friction. First question 4.1, as I've said in the past 2 videos, is that it will always be either a definition or a definition that we need to state, or law that we need to state. In this case, 4.1, state the principle of conservation of linear momentum in words. In an isolated system, total linear momentum is conserved. Straightforward, short definition, straight to the point. Another way we could say it is, in an isolated system, total linear momentum remains the same. Then we're going to have a look in question 4.2. Carrying on with the question. Calculate the velocity of dancer A in figure 1, okay, the unknown velocity of v. Okay, so what do we know about this question? We know that the mass of dancer A is 52.5 kilograms, so we write that down on the side. We also know the mass of dancer B, okay, is 42 kilograms. What else do we know? The velocity, the initial velocity of A is unknown. So VIA is equal to V meters per second. Okay. But you're trying to figure out what is the numerical value of that. And we also know that 4 meters per second was the initial velocity of dancer B, but that's going in the opposite direction to east. East is positive, west would be negative direction, negative 4 meters per second, west direction. There we go. Okay, so we're trying to find out what is this value. So we use the formula total linear momentum before is equal to total linear momentum after. So PI is equal to sigma PF, which means the mass of object A, or mass A, times the initial velocity of A, plus the second object's mass times the second object's initial velocity is equal to the mass VF minus V. Sorry, that's incorrect. It's actually, let me just correct this quickly. Sorry, I wrote the formula down wrong. It's VF of everything on this side, so we take VF out, and mass A plus mass of B. Okay, now we know that VF was equal to 0 here because they say they come to a rest as shown in figure 2. So everything here is going to be equal to 0. Okay, because there is no velocity. So we have 52.5 V, okay, because we don't know what is this value, plus 42 times negative 4. Okay, we put that in our calculator. We have 52.5 V minus 168 equals 0. We end up with 52.5 V is equal to, we take this wally over here, and we have, sorry, that looks like a square root actually. There you go. Take him over here, and then we end up with positive 168. We're going to divide both sides by 52.5. Like I said, I'm sure you all know how to do an equation. So 168 divided by 52.5 should give us a value for the velocity of person A before they come to a rest, or before they interlock, the dancers, is 3 6.2 meters per second, and that we can say is east, or we can say that's to the right. Okay, right or east, whichever one you'd like to decide, as it says that mass B goes west. So, and they say the answer A goes east. Right, moving on. After grabbing each other, new scenario now, the scenario changes slightly. After grabbing each other, dancer A pushed dancer B away with a net force of 670 newtons in 0.5 seconds. And dancer A moves to the west as shown in figure 3. What is the force exerted by dancer B on dancer A? That is for 1 mark. That answer was mentioned to us in the scenario above. It is 670 newtons west. Alright? Force is a vector. After grabbing each other, dancer A pushed dancer B with a net force of 670 newtons. Alright? And dancer B must have exerted a 670 newtons force back on dancer A for dancer A to move in the westerly direction. Okay, so we must add the direction on at the bottom there, or at the end of our question, in order for us to obtain full marks. And then for the final one, 4.4, calculate the magnitude of the velocity of dancer B in figure 3. This is where our formula for impulse comes in, which is F net delta t is equal to the change in momentum, which we know F net delta t would be equal to the change in momentum, which is equal to the mass of the object, all right, brackets Vf minus Vi, because mass is the common factor. So we sub in 670 newtons times 0.5, basically half of 670, is equal to mass of dancer B, doesn't change, it's still 42. Okay, and we are looking for the final velocity. So remember, they were at rest initially, so it's Vf minus 0, which just leaves us with 42 Vf. 670, half of that, gives us a value of 335. Is equal to 42 Vf. Divide both sides by 42. Alright, and we should end up with the final answer for the final velocity of dancer B after it's pushed away by dancer A is 7.98 meters per second. And that is our answer and final answer for question 4. With that, we wrap up question 4. 11 marks for the momentum question. Please stay tuned. We'll look at question 5 in the next video.